researcher at the KIT with a specialization in Python development, MLOps, and testing. He provides support for services in EOSC projects, and today he will present AI4OS, a comprehensive toolbox to develop AI models in the EOSC.
Thank you very much for this chance to present here at the HAICON conference. So, what is AI4EOSC project? So, AI4EOSC is a software stack. Meanwhile, AI4EOSC is a project. AI4EOSC project is the evolution of this deep hybrid data cloud platform where we try to provide tools to scientists that will help them to move their models into something running. In this case, the tool will integrate into their model in order to generate API endpoints so users can trigger the execution of their models using a simple web protocol service. AI4EOSC project tries to extend further and evolve, and not only to offer these API endpoints, but also to integrate MLOps tools that to bring scientists to closer and in an easy way that can start to implement their models into this MLOps environment. The project ends in August, and we have been able to achieve a lot of things during this process. So why AI4EOSC? So AI4EOSC is a platform, it's a toolbox, as I was mentioning, and it's tend to run AI models. And to do so, you have multiple tools, so you can synchronize, it offers synchronization with the data repositories, like from Zenodo, or other private clouds providers like Google, or where you might have your data. Also offers computing resources in a transparent way, so you can have a place where you can run your models. It also helps researchers to build AI and to move them into production, and also focus on privacy. So, for example, offer tools that you can use to train your data to do not compromise in the privacy of sensitive data like medical images that you might not want to share with everybody. It also provides tools for monitoring, that's the core of the MLOps, track the accuracy or the loss of your training models and a place where to store them. And also you can benefit, or we enforce users to implement best practices for the development of those AIs that sometimes is difficult. This is how the platform looks. So we have at the left a panel where you can select which tools you might want to use, which I will introduce in the following slides. And in the middle, you can see our catalog of options. Here is where our customers already have published some of their models, and their users can just come here to this platform, click on one of those, and they can actually try it with just a few clicks. And after these few clicks, they can start to put the data and get some results without you as users having to do too much. So the first thing is data storage and ingestion. You want to connect your data with your service because you store your models or your parameters in some places, and then you want to connect it to your cloud. So we offer multiple options: synchronization with Zenodo, Hugging Face, or any other cloud platform, like for example Nextcloud. We have also tools for data annotations. In some cases, if your service is image-based and you don't have capabilities to label all the data, we have tools that are already searching to the market, which are the most convenient for our environment as a scientist to use. In this case, we decided for CBAT. And it offers, for example, automated ways that you can use if you don't have the resources to label every single image. You can configure pipelines to do that automatically, for example. Model development. So you saw a catalog with a lot of models. You don't want probably to start from the scratch. You can just simply select a model, and you can retrain it with your data, and you can fine-tune it. You can use incremental learning, and you want to extend, for example, a fees detection application to, I don't know, another type of fees, or to some specific kind of small region for specific local fauna, or whatever you would like. We implement also interactive development environments. You can choose between VS Code or Jupyter Lab. With a few clicks, you will go into a web page where all the extensions and tools that a machine learning developer might need in order to do this extension of the original model or a model from the scratch, and yeah, start to try and to run and to test how their changes work. Now it comes training. Once you have the development ready, you want to train your data. You might train it individually. You might want to train it in parallel. We offer different mechanisms, so you can use CPU, you can use multiple GPUs, and we also provide tools for federated learning. So if you are in a collaboration with multiple other data providers, for example, hospitals, but you don't want that the other hospital to have your client or your patient's data, then federated learning is the key, because we like to enforce your services to use EOSC standard. And then you can publish you can train, share the data, and train all together the model at the same time without having the other clients know about the details of that personal data. Now, the core of the platform at the end is also to serve the model. We want to make easy that your users can run your models. And to do so, we offer multiple options as well. So the most common and the most recommended are the standard ways to use serverless. So it's based on Docker containers. Basically, we will put your model into a Docker container. User triggers the execution of that Docker container, and when the job is finished, the Docker container is closed, and the user has your results. That way, we save a lot of computational resources, which at the end is money and this energy, and we want, of course, be efficient. Nevertheless, if you have more complex flows, we also offer tools like FlowFuse or AI4Compose that you can configure. Or if you want to have a continuous server because you have a graphical user interface that needs some place to run, you can also have normal servers. Now, model monitoring. Here is where a lot of places the users or developers get lost, because it's the core, not for platform, but the core of machine learning operations, is where you have your model running and you want to track how your model is performing. Because after maybe 2 years, the concept has changed, and then you need to track if your model is still useful or is representative to those changes. We also have searched the market and to evaluate which are the best tools that we need to, or that we should provide to our community, most fits with our community. We decided for MLflow. MLflow, it's a kind of place where, for tracking experiment, you can think it like a kind of Git tool or GitHub tool where you are going to store your models, you are going to version your models, and you are going to keep the metrics of your models, for example, like accuracy, loss, and you might decide to move quickly because a new development from one of your developers is just something really new, and you can put it into production use easily. And drift detection, it's a place where, the platform has worked with Froros. It's a place where it's a tool to analyze the metrics and how the statistics of your model changes over the time. The data might change, and you want to have a place, a tool where you can evaluate those. We also have a service called Drift.Watch, where you can store those metrics and see how they evolve through the time just to see if, for example, you have a camera in an aquatic environment, and this camera is taking some pictures, but with the time, algae grows through the camera, and it's not taking the pictures as good as always. Then you can have that is to know when you have to go and clean the camera in order to do not have this variation in your data. Now this new feature, nevertheless, it's something new, because now it's coming this new word which we call LLM Ops, which is something very new, which is part also of the machine learning operations, but focused for an LLM. Just similar like the catalogs were more generic for any model, we have also a subsection in the case that you want to try and use or to provide new large language models. And here I leave you a QR code that you can use to access to the dashboard and to try it by yourself. Try to go and run some of the available models in the catalog. And yeah, as a conclusion, So it's a tool that provides, wants to bring scientists closer to this MLOps environment, to provide you with tools or to servers where you can run and deploy your models in the efficient manner. Offer also the tools that you might need in order to train your models correctly, especially in our this European Open Science Cloud, where we care really much about the privacy of our data. We offer all the tools that you might need, extensions, environment, and yeah. And that's all. So thank you very much for attending to my presentation, and I will leave now time for, I will be glad to answer any questions you might have.
Thank you, Borja. Questions from the audience?
Thanks for the talk. It's very interesting. I want to ask for, you mentioned that you provide some annotation automatic platform interface for users to do annotations more easily. I'm wondering whether you have integrated some already existing models for it, for example, segment anything or segment anything medical, this kind of already existing models to help the user already to do the annotation process more easy?
I'm not aware of, I mean, I know we have examples where they use CVAT, and our developers have already tried and tested that it's working very fine. Honestly, I don't know. We have a lot of different applications in catalog. Cannot tell you one specific where you might took. Maybe this that is in the example about car recognition. But yeah, I believe there are examples where yeah, this automation system for labeling is working. At the end, it's based on CVAT. So you can go to simply CVAT and see which examples they do have. And if we change something from, I mean, the other values that we did our research to see which are the tools that you might need to work correctly on our European projects. And this was the best with the best score and with the site integrities. If we modify something, sometimes it's about the authentication, not about the capabilities of the tool. Okay. And then you can look for CVAT examples. I'm perfectly sure they will work as well in our platform.
May I ask another question? Because ML Flow, as I understand, it also provides a lot of this kind of ML ops, this deployment, model development, how to say it, the assistant also to work on the machine learning development, this streamline. How much is this the tool, the platform you are offering here overlapping with the ML Flow? I mean the features.
So it's the same. We offer, I mean, we have a server with ML Flow running, and you can just use it like in your normal computer. We offer the field features. So the only difference is instead of having to work with your local host, where your models will be stored locally in your machine, you have a place in the cloud where you might store them. But you can use those endpoints to retrieve the models. You can use the version to retrieve exactly which is the model that you like. I believe I mean, I'm pretty close with this ML Flow development. We don't. And the only thing that we did modify is the authentication process. We use OEDC because it's a more federated tool, but yeah, we offer model versioning and we offer the experiment tracking, which are the two main features of.
Thanks.
All right, let's thank Borja again. Thank you.